from the Greek words trigon and metron, which mean measurement of triangles. So we will be dealing the measurement of triangles, particularly their sides and angles. Okay, let's talk about the trigonometric functions of an acute angle. Let's consider this right triangle. The angles of the right triangle are denoted by the capital letters A, B, and C, while the sides of the right triangle are denoted by the small letters A, B, and C. So the side opposite to angle A is the side A, while the side opposite to angle B is the side B, and the side opposite to angle C is the side C. So the side C here is the hypotenuse of the right triangle, while the sides A and B are the sides or the legs of the triangle. We define the trigonometric functions of acute angle A. This angle, we define its trigonometric function as follows. Sine A is equal to the side opposite A over the hypotenuse or if we look at the triangle, the side opposite A is the side A, the small letter A, and the hypotenuse is the side C. So sine A is equal to A over C. The cosine A, cosine of the angle A is equal to the side adjacent to A over the hypotenuse. So if we look at the right triangle, the side adjacent to A is the B. The hypotenuse is the C. And tangent A is the side opposite A over the side adjacent to A. Or it is the small a over small b. So we can write the sine the cosine, and the tangent can also be written as the sin, the cos, and the tan. the short way of writing. The short way of writing the sine, the cosine, and tangent are these ones. So the other trigonometric functions of angle A are as follows. Cosecant A, this is just the reciprocal of the sine A. So based on the right triangle, the sine A there is A over C. So the reciprocal of A over C is C over A. And secant A is equivalent to the reciprocal of cosine A. So based on our right triangle, cosine A is equal to B over C. So the reciprocal would be C over B. And then the last trigonometric function is the cotangent A, which is the equivalent to the reciprocal of tangent A. So that is 1 over tangent A. Tangent A is equal to A over B. So the cotangent A would be equal to B over A. So cosecant, secant, and cotangent could be written as cosecant is written as C, while the secant is written as sec, and the cotangent could be written as cot. So when we write trigonometric function, the sine, the cosine, the tangent, cosecant, secant, and cotangent, when we write them, we should be writing them together with the angle. So it should be written as the cosecant A, the cotangent A, the secant A, the sine A, the cosine A. Let's continue. If two sides of the right triangle are given, we would be able to find the other missing side by using the Pythagorean theorem. So the Pythagorean theorem states that the square of the hypotenuse of the right triangle is equal to the sum of the square of the other two sides. So the other two sides are A, so A squared, and then the B should become B squared. So again, the Pythagorean theorem states that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides. So in using ABC, the small letters ABC as the sides of a triangle, a Pythagorean theorem in formula would be C squared is equal to A squared plus B squared. So for example, we have a right triangle of a side A equal to 3 and side B equal to 4, we will be able to find the measurement of the side C using the Pythagorean Theorem. So C is equal to the square root. So square both sides, you'll be able to get a C, and then we'll have to get the square root of the A squared plus B squared. So C is equal to the square root of 3 squared plus 4 squared is equal to 9 plus 16. 9 plus 16 is 25. So the square root of 25 is equal to 5. So C is equal to 5. So if we know the measurement of the sides A, B, and C, we would be able to find the trigonometric function of the angles of the right triangle. So here, let's find the sine A. So sine A is equal to the A over C. So A here is 3 and C is 5. So that would be 3 over 5. Next, cosine A. According to our formula, that is B over C. So B is equal to 4 and C is equal to 5. So cosine A is 4/5. Next is the tangent A, which is equal to A over B. So A is equal to 3 and B is equal to 4. So tangent A is 3/4. Then we could also find the other 3 trigonometric functions. The cosecant A, which is the reciprocal of sine A, so that would be C over A. So the reciprocal of 3/5 is 5 over 3. And then next is the second A, which is equal to the reciprocal of cosine A. C over B, or the reciprocal of 4/5 is 5 over 4. And then the last one is the cotangent A, which is the reciprocal of tangent A. So the formula would be B over A. Or the reciprocal of 3/4 is equal to 4 over 3. So these are the 6 trigonometric functions of angle A. Let's have an example. Solve for the unknown side and find the 6 trigonometric functions of angle A. Given A is equal to square root of 5 and C is equal to square root of 11. So using the Pythagorean Theorem, we will be able to find the angle on the side B rather. So let's draw. So let's say that this one is the square root of 5, and see here is the square root of 11. So now let's find the angle B. No, sorry, the side B. So this one is the formula for the Pythagorean Theorem. So we're finding the B. So transposing B. So B squared is equal to C squared minus A squared. So we'll be able to find the measurement of the side B. So C squared is equal to square root of 11 times square root of 11 is 11 minus A squared is equal to square root of 5 times square root of 5 is equal to 5. So B is equal to 11 minus 5 is equal to 6. So B is equal to the square root of 6. So we now have the measurements of the sides ABC of the right triangle. Now we will be able to find the 6 trigonometric functions of angle A. So first, let's do the sine A. It is equal to A over C, or the opposite over the hypotenuse of the right triangle. So A is equal to the square root of 5 over C is equal to the square root of 11. Now let's retain at this time. Let's just retain the answer with this radical, because later on you will be studying in your algebra that we need to simplify radicals in the denominator. But for now, let's retain this answer with radical in the denominator. And then cosine B is equal to B over C, which is equal to square root of 6 over square root of 11. So again, let's retain the radical in the denominator. And then next, the tangent. I'm sorry, this is not B, it is A. We are looking for the trigo functions of angle A. So the trigo function should go with the letter or the angle A. So tangent A is equal to A over B, or the opposite side over the adjacent side to A. So A is equal to the square root of 5 over the square root of 6. So again, let's retain the radical in the denominator. And then next, cotangent A. Cotangent A is the reciprocal of tangent A. So B over A is equal to the square root of 6 over the square root of 5. And then the other two functions, the cosecant A is equal to the reciprocal of the sine, which is C over A. This one, square root of 11 over the square root of 5. And then the last one is the secant A, which is equal to the reciprocal of the cosine A. C over B is equal to the square root of 11 over the square root of 6. Now let's look at the trigonometric functions of complementary angles. Two angles are said to be complementary if the sum of the measures of the angles is equal to 90 degrees, meaning given our triangle here, angle A plus angle B is equal to 90 degrees. By referring to the definitions of the trigonometric functions and our given triangle here, we can derive the 6 trigonometric functions of acute angle B. So let us start. Sine B is equal to the side opposite B over the hypotenuse. And then cosine B is equal to the side adjacent to B over the hypotenuse. And then tangent B is equal to the side opposite B over the side adjacent to B. So looking at the triangle, the side opposite to angle B is the small letter B, and the hypotenuse is a C. Cosine B, on the other hand, is equal to the side adjacent to B. Adjacent to B is the A. The hypotenuse is C. And tangent B is equal to the side opposite B, which is the small b, and the side adjacent to B is equal to A. So our tangent B is equal to B over A. So the other 3 trigonometric functions are just the reciprocal of these 3 trigo functions. So we can find cosecant B is equal to the reciprocal of sine B. It will be C over B. And then next is the secant B, which is the reciprocal of cosine B. So that will be C over A. And then last is the cotangent B, which is the reciprocal of tangent B. So that will be A over B. So these are the 6 trigonometric functions of the complementary angle B. Which is the complementary angle of A. Comparing the trigonometric functions of angle A and angle B, and noting that angle A plus angle B are complementary angles, that is A plus B is equal to 90 degrees. So we can make the following generalizations. Sine B is equal to sine 90 degrees minus A is equal to cosine A. Cosine B is equal to cosine 90 degrees minus A is equal to sine A. Tangent B is equal to tangent 90 degrees minus A, which is equal to cotangent A. Cosecant B is equal to cosecant 90 degrees minus A, which is equal to secant A. Secant B is equal to secant 90 degrees minus A, which is equal to cosecant A. Cotangent B is equal to cotangent 90 degrees minus A, which is equal to tangent A. We can say that in any pair, either function may be called the co-function of the other. We can have a single statement to generalize that the function of the complement of an angle is equal to the co-function of the angle. Now let's find the other functions of an acute angle when one function is given. To easily determine or remember the trigonometric function formula of an angle, we use the mnemonics SOHCAHTOA. So SO means the sine, which is equal to the opposite over the hypotenuse. So this is the sine of any angle, no? And then the ka is the cosine of any angle is equal to the adjacent over the hypotenuse. And then the TOA is the tangent. Tangent of any angle is equal to the opposite over the adjacent. So we use SOHCAHTOA to remember the trigonometric functions of any given angle of a right triangle. So now let's proceed with finding other functions of an acute angle when one function is given. So let's look at our example. Given sine A is equal to 12 over 13, A is acute. Find the other trigonometric function values of A. So we can draw the triangle. So we know that sine A is equal to 12 over 13. So using the SO, sine is equal to 12 over 13 sine A. So the hypotenuse here is 13 and the side opposite to A is 12. So we can label a triangle as this one. The side opposite to C, angle C, is the hypotenuse, which is 13. And the side opposite to angle A is 12. So the missing side is B, or the side opposite to angle B. Now, using the Pythagorean Theorem, we can find the measurement of side B. So B is equal to the square root of C squared minus A squared. So B is equal to 13 squared minus 12 squared. So 13 times 13 is 169. 12 times 12 is 144. So 169 minus 144 is equal to 25. Square root of 25 is equal to 5. So B here is equal to 5. Now we can find the other 6 trigonometric functions. So we already have the sine. So let's start with cosine. Cosine A is equal to the side adjacent to A over the hypotenuse, or the B over C, which is equal to 5 over 13. Then tangent A is equal to the side opposite to A and the side over the side opposite to, or adjacent to B. The side adjacent to A, which is B. So A over B is equal to A 12, and then B is 5. So the other 3 triangle functions are just the reciprocal of the first and 3. So the cotangent A is equal to B over A, or 5 over 12. Then the cosecant A is equal to the reciprocal of sine. Sine is opposite over adjacent, or A over C. So this is the C over A. C is a 13 over 12. And then last is the secant A, which is the reciprocal of the cosine. So C over B is equal to 13 over 5. So here we found the other 5 trigonometric functions of an acute angle given one trigo function, which is in this case the sine A. So we're done. So thank you so much for listening and for watching. So see you next time.